I assume you're somewhat familiar now with generating basic particle simulations and using some forces to control them, as well as rendering some dots using Redshift. Now, it's very important to introduce the next very fundamental concept of particle groups. You might remember that if I create some sort of emitter, it automatically creates a particle group. Let's talk about this for a moment. If you select the emitter, you will see that in the properties, the first of the properties says group and has the name of the particular group. Now, what I'm going to do is call this first emitter, and I'm going to call this group group 1, just so that we have a variation of the names. You will see that the first emitter now, the name has changed because this is an explicit link. So anything we generate using this emitter is being generated in this group. And you remember we use that in the cloner. So let's do that for a moment. I'm going to create a cloner. I'm going to create a cube, make it smaller, make the cube a child of the cloner, bring it down here, and tell the cloner to be in object mode, and let's drag this group in here. So this is nothing different than what we did earlier with that beautiful simulation that generated a few thousand cubes. So here's the question: what if I want a different emitter to emit different objects? So let's go and create another emitter. I'm just going to click Basic Emitter. It's going to create the emitter in exactly the same position as the previous one. So I can just get my move tool and move it out of the way. And it's called Basic Emitter again. I'm going to call this second emitter. And I'm going to call this group 2. You can use any names you want. So the second emitter now is linked to group 2. So group 2 holds the particles for the second emitter. Now, just because I'm going to go nuts, I'm going to drag these here so we have the first emitter here and the second emitter here. Otherwise, my brain doesn't function properly. So just like we did earlier, I'm going to call this cloner 1 and make a copy. I'm control dragging down here, call this cloner 2, and instead of a cube, I'm going to make a beautiful sphere. Make it smaller and make it a child. Now, the cloner is still linked to group 1, so you can always go and change it to group 2. And let's rewind and press play and let's see what happens. So you can see now that group 1 is emitting the cubes because we've linked the group 1 to cloner 1, which is cloning cubes. And the second emitter is emitting in group 2. There you go, second emitter in group 2. And group 2 is being used in cloner 2 to create the spheres. All right, everything seems very straightforward, but not very helpful. Well, let me show you exactly how you can use a group to do more fancy stuff. Let me just fold these so there are fewer things here to look at. Now, I'm going to create, from the Simulate menu, a turbulence, and just set the settings somewhere around here. When you do this little triangle, 1, 2, 3, things look beautiful. That's my rule of thumb. Press play, and you will see that both particle streams are reacting to the turbulence. And funny enough, this is one of the most fundamental ways you're going to use the particle system. Any force that is not a child of any group will be applied to all groups. Now, if that sounds a bit complex, let me show you a little thing. So again, you can see all the particles are receiving that turbulence, and they're sort of flying away from their straight trajectory. If I take the turbulence and I make it a child of group 1, watch what will happen. Rewind, press play. You will see that group 1 accepts the modification that the turbulence provides, and this turbulence is applied to these particles. But group 2 doesn't. Now that's fascinating. Now what I'm going to do, I'm going to grab these two and I'm going to cut them. So I have them in the clipboard so we can only see particles. It may be a bit clearer to see it that way. So all particles look the same, and yet the group 1 particles are the ones that react to the turbulence. Now let's try something else so you can understand even better what the system does. Let's go to the Simulate and let's create a gravity. And let's make it a bit less so they don't really fall down fast. I'm going to leave the gravity in the root level, so I'm not making it a child of anything. And try and guess what's going to happen. I'm going to rewind. Do you have enough time to think about it? Let's press play and see. Look at that. So the gravity, not being a child of any of these groups, is being applied to all the particles. Whereas the turbulence, being a child of one group, is only applied to group 1 over here. And I can actually take it and put it in group 2, rewind, and press play. And now you will see that the turbulence and the gravity is applied to group 2, but only the gravity in group 1. And this is the bedrock to understand how we control particles on a more granular level. So now that we've talked on the very surface about one of the main functionalities of the groups, I'm going to introduce one more thing. It's called the multigroup. Now, what happens if I want to use both these groups to use them using a MoGraph cloner to clone some cubes? So I'm going to paste back my cloners and get rid of cloner 2. So I'm going to keep cloner 1. Now, remember cloner 1 is linked to group 1. So you will see that only one is going to generate objects. But I want both of these groups to generate the same cubes. Now, you may be inclined to make a copy of this and use the other group. It will work, but then you have 2 cloners. If for any reason you want to combine groups in a way that you are going to use those particle positions to do one thing, then you can use the multigroup. So let's create a multigroup. Let's drag it down here. In the multigroup, I'm going to put the groups, group 1 and group 2. And for the cloner, instead of cloning on group 1, I'm going to clone on the multigroup. And let's rewind and press play. And now you will see that although the particles still retain their individual operations, whatever we've done here, group 2 has turbulence and both groups react to the gravity, yet they are grouped in this multigroup, which then we can use in a cloner or in some other circumstances. So groups and multigroups are going to become a very frequent thing you're going to use in your particle simulations. Remember, this is just an overview, and we will see more things that relate to groups in the more detailed series that will follow. In the next video, we're going to add conditions to the mix to show you how powerful this concept can be.